Hello and welcome to another edition of a Manitowoc Monthly Spotlight. This is August 2023, and today we're going to be talking about our Flaker Nugget line and how to do some basic diagnostics and troubleshooting with them. So with that being said, I'll bring the presentation up here and we'll get started. So as usual, we're going to have an opportunity to take a quiz at the end of this so we can apply what you learned in the video. There'll be a link, both mobile friendly and computer PC based friendly. So in order to get a copy of this presentation and a certificate of completion in PDF format, you'd obviously have to complete that quiz, fill out some basic information such as your email address, and then once that quiz is completed and we receive it, we would email that information out to you at that time. So let's kind of get started here with what a Flaker Nugget is and how to identify which model we may have or that we might be working on. So good thing about Manitowoc model numbers is that they're all pretty similar and they follow the same format. So the first digit we're going to be looking at is going to be an under counter model. In this particular example, the second letter is always going to be our cube size. So this is a Flaker machine that we're working on today. And our refrigerant type is P for propane. If you're on a Flaker Nugget, if it's an older unit, it's going to be a 404A unit. If it's some of the newer ones and some stuff that you might see in the future, more and more, we're going to be seeing a lot more propane units. After that, we're going to have our series, and that number usually correlates to the approximate capacity per day for that machine in pounds. And then our condenser type, this is an air-cooled, self-contained air-cooled. We have our voltage that follows that. 161 would be your conventional 110 here in the States. 261, of course, would be a 208, 230 volt, etc. And you may see a letter Z at the end, which would indicate it comes with a cord with a plug on the end of it. So very similar to what all of our other model numbers are, just a few different digits that you might see. So we're going to start off today talking about the smaller capacity under counter Flaker Nugget machines. And we'll get into the modular units too. The one thing that I want to stress across the entire Flaker Nugget line is the diagnostic procedure is pretty straightforward, pretty much similar with all the machines that we have out there. There's a few differences, of course, and we'll highlight those. But key to take away, we're not using a control board here. We don't have sophisticated sensors or control systems that we need to diagnose. We basically have safeties that are tied in series, and if all those safety conditions are met, we're up and running and in business. But there are a few differences between some of the machines, so we'll go through a few from each different category. So on a UNF under counter 200 or 300 safe, the unique thing about these is they don't use a timer. There's no time delay, anything like that you would see on some of our larger models. Just going to have simple on-off switch and a few different safeties. So we're going to have, of course, a bin thermostat safety. We're going to have evap low temp. So we want to make sure that we don't freeze that evap up. So we're going to have a low temp pressure safety. We're going to have a water level switch. So of course, if we don't have water, we should not be trying to make ice. So we want to ensure that we have water. So that's going to be one safety. And we'll also have a low water safety. So if we get too low on water. We have fan cycle control, just like on most refrigeration systems that are using an air-cooled condenser. We want to be able to modulate that head pressure to control it. So we do have a fan cycle control. Pressure switch, and of course the condenser fan. Now, although it is crucial for that fan cycle control to work properly, that will not necessarily keep your machine from starting. So don't necessarily believe that if you have a bad condenser fan motor that's what's causing your machine not to start at all. Really what we're looking for here are the safeties other than number 13 on the screen. All of those safeties to be closed. So they're going to be in series. So if one of them opens, it's going to cut the power feed to the motor contactor and the water inlet valve, etc. So we need to make sure that these safeties are electrically closed. And this is going to be common among all the Flaker Nugget line. If we have an open safety, that machine is not going to start up. So if you have come to a machine, of course, we want to verify that we have incoming voltage to that machine, because if we have a cutout breaker or bad cord or bad outlet, of course, that's going to stop us dead in the water to begin with. So we always want to verify incoming voltage. That's going to be our first step in a machine that's not starting up. Once we verify that, we're going to turn that power switch on. You'll see on this particular 620 behind me that there is a green button on the upper left side of the machine. If you turn that on, that light comes on, you can be pretty much rest assured that you at least have incoming voltage to that machine. Now, on this particular diagram that we have on the screen here, what we're going to want to do is trace our voltage from hot side, which would be brown wire L line, through those switches. And you're going to want to make sure that you have voltage at each point progressing through all of these switches. If we have one open safety, we're definitely going to have a situation where that compressor motor is not going to start up and we're not going to be making ice. Now, if we find that all of the safeties are in fact closed and that we have continuity through them and we still have a compressor that doesn't want to start up, then we're going to start wanting to test that compressor itself. Maybe we have a shorted motor in the compressor, start components, something of that variety. But the first step and the most crucial step is to make sure that we follow that flow of electricity through all those safeties. One open safety is going to stop this machine dead in its tracks. So let's move on to a modular unit. This is a smaller modular unit, a 320 series. And this is fairly common with the larger larger pieces of equipment too. You'll just see bigger evaporators and whatnot, but the layout's pretty similar. You can see our bin level and evaporator thermostats in the top left-hand corner there, that on-off switch that I talked about. A time delay bypass, we'll get into what that time delay means in a little bit. We have our compressor and evaporator over on the right side with the exhaust or discharge, as I like to call it. The micro switch, that's gonna tell us if that ice starts to back up into the evaporator. We know that we're full. That's a safety that's gonna shut that machine down so we just don't keep pushing ice all over the place. Of course, the evaporator and our gear motor, which is turning the auger inside of the evaporator, that's augering the ice out through the exhaust or the discharge. So pretty similar layout on all of our modular machines, this one being a 320. So the 320 is going to be just like the undercounter 200 and 300 we just talked about earlier. We are going to bring our incoming power through that on-off switch. Our line wire or brown wire is going through a succession of different safeties. We got our, of course, bin thermostat safety. That's going to give us the bin level or that we can set and choose. Our evaporator safety thermostat. Here we also have a high pressure safety switch, or if we do get into a condition where, say, the condenser fan motor fails, or we have a blockage in the system on the high side of the system, etc. If we get too high of a head pressure, of course, this safety is going to open. Now you can see some pressures there on the bottom of the screen, cut in and cut out. Pay attention to the fact that these would be for 404 based systems. The pressures that are going to be on a propane-based system are going to be different, of course. So we always want to pay attention to what kind of system we're working on. Now, if we need to know exactly what those pressures are, we can always find those pressures in our technician's handbook. Those are always listed in there, and they'll be pertinent to the model number of the machine that you're working on. You'll also notice in this particular instance, you can see the pressures open and close right on that pressure switch itself. They're in bar here, but a simple conversion on your smartphone or computer, laptop, what have you, simple converter can get you where you need to be if they're not in PSI, which most of us here stateside are used to using. So key takeaway from this is be wary of the machine you're working on. If you're testing this switch, there's going to be different cut in and cut out pressures for either a fan cycling switch, high pressure cutout, even a low pressure cutout. It's going to be based on the machine itself. So don't take for granted that if you know one, that they're all the same. But with that being said, we're going to want to make sure that that's closed, of course. We have that ice chute safety switch that I talked a little bit about before. Basically, that is on the discharge of the evaporator. What that's looking for is to make sure that we don't have ice backed up into the ice chute itself. If we do, we probably have a blockage, or we have simply a full bin and we need to shut that machine down, of course. That would be if our bin thermostat switch had failed for some other reason. That's a backup safety for that. Now, of course, we have our water level switch that's going to determine when to turn on and off our water inlet valve. We have a low water level safety that's common to all of our machines. If we don't have water, we got to make sure that we shut that machine down. Otherwise, we're sitting there doing nothing, basically. And of course, a gear motor down below there, and a compressor time delay. So on this particular unit, we're using a solid state timing relay. What this is doing is just giving that system time to fill up with water, get everything turning before we just automatically go and start up that compressor. We want to make sure that we got the system working, operating properly. It doesn't pay to start a compressor on a system that's malfunctioning. So it just gives us 8 minutes of time to get that system up and running and kind of normalized per se. So of course, for the first 8 minutes of operation on a 320, you're not going to see that compressor motor engage. It's going to be timing, waiting for that delay to end in this scenario, 8 minutes. Now there is a time delay bypass that I talked about. There's going to be 2 black wires with a connector that has nothing plugged into it. You can see on the wiring diagram here, it's labeled as number 35. That is a bypass. So what that bypass will do, if we need to troubleshoot or something's going on, we want to make sure that compressor runs and we don't want to wait the 8 minutes. We're going to want to jump that with a paper clip, piece of wire with 2 connectors on the end, whatever you have available. Careful, this is line voltage, so be wary of that when you're doing this. We're going to plug that in, and that's going to bypass that time delay, and hopefully that compressor is going to start up, indicating that, okay, compressor's working or functioning as the way we need it to. Or maybe if it still doesn't start up, perhaps we have a problem with that compressor, and maybe there's a problem with this solid state timer to begin with. But that bypass is meant just for troubleshooting. Please don't leave that in. That's a safety. We need that time delay to be part of that function of that machine. Here, here's a picture of that jumper that I was talking about earlier. As you can see, the black wires and that's white connector there. Here we just have a piece of wire with 2 spade terminals on it. You could use a paper clip, something of that variety, to do the same thing. So that time delay, once that expires with that solid state timer, you can see that it's energizing K, circled in the small red box on the bottom. That's basically the coil for the compressor contactor. That's going to pull our contactor in, and we should be off and running into the races. And again, we do have a fan cycle control on this system. Now, remember that that's wired in parallel, so the system may still start up, may function properly initially, but if you're having an issue where we have low production or it's cutting out on high pressure, something of that nature, we're going to want to look at that fan cycle switch, make sure that that's opening and closing as need be based on the pressures that are spec'd by the particular machine. But remember, this machine will start whether or not that fan cycle control is working properly or not. So a faulty fan cycle control will not be the reason for a no start condition on a Flaker Nugget. So 620 and larger here, very similar systems. We're going to have the same kind of safeties that we're looking for on the smaller models, but we're going to bring in the addition of a rotation speed sensor, and we'll talk a little bit about that. But first, let's just go through these safeties. Of course, we're going to turn that machine on, and then we're going to, if all these conditions are met, the bin thermostat is closed, high pressure cutout switch is closed, ice chute safety switch is closed, excuse me. Low pressure switch is closed and our low water level switch is closed and the rotation sensor is satisfied. We, of course, will be energizing our motor contactor for our compressor and it should start. But the first step, of course, is always to turn it on. So we'll kind of take a look at some of these components and how they look like in the wiring diagram. So, of course, we have our on-off switch, the bin thermostat that controls the level that's going to be in our storage bin, of course. Our low pressure cutout on this particular unit, we also have a low pressure cutout. So if we start running into low suction pressures, we're going to cut that cutout switch and that will, of course, shut the machine down. High pressure cutout, just like we saw earlier. Ice chute safety switch, nothing new there. Then we're going to have our low water safety. Now, of course, low water safety will cut us out. We also have our water level switch. Now, the water level switch is not going to prevent us from starting if we have a failure with that switch itself. We probably will eventually because we're going to run out of water more than likely, and that'll trip our low water safety. But that water level switch really isn't a safety in this scenario. That's just controlling the water inlet valve, telling it when to turn on and off. So it's part of the control system, but it's not what I would consider a safety in this scenario. And of course, we have our gear motor, and that gear motor is what's going to auger the ice out of the evaporator once that ice is formed. Rotation sensor, I just brought this up earlier, a couple slides ago. Here on the 620 and all larger machines after this, we're going to bring in a rotation sensor. So this rotation sensor is essentially checking to make sure that that auger inside the evaporator is turning and in fact moving. So if we have a failure with the gear motor, we're going to lose RPM. That rotation sensor is going to sense that. It's going to shut that machine down. Of course, we don't want to be running a refrigeration system if we don't have a working auger system in the evaporator. We're just wasting energy at that point. So what does the flashing light on this RPM rotation sensor signify? So you're going to see one of 4 different conditions. You'll see initially when you first start the machine, you'll see that yellow light blinking. That yellow light blinking is indicating that we are in an 8-minute time delay period. So much like on the 320, we also have an 8-minute delay here on startup, except instead of using a solid state timer, we're using this rotation sensor itself to take care of that function. So if you see a yellow light blinking, that means that we are in the middle of a time delay period. We need to wait for that 8 minutes to expire, and the RPM, or excuse me, rotation sensor at that time should start to turn solid yellow. You'll see a solid yellow LED. Basically, that means we're past our 8-minute time delay and that we are in normal operation. Everything is good. We should be making ice. Now, if you see red fast flash, 2 flashes per second, what we call fast flash, that's indicating that we had a fault. So up to 7 times, we are going to try to, we're going to stop, reinitiate that 8-minute time delay period, and hopefully after that 8 minutes expires, we'll have rotation again. But if you see the red fast blinking light, that indicates that we have lost RPM at some point in time and that we are starting over on that time delay period. Now, if you see that red light go solid, or you come up to a machine where that red light is solid, that means it has tried 8 times to establish RPM and it has failed all 8 times. We are in a shutdown at this point. The machine is just idling, sitting there neutral. So in order to clear that out of that RPM sensor, you would need to remove and restore power to that machine to get that to clear. And of course, you'll go back into the initial time delay of 8 minutes, yellow blinking. If in fact we have RPM at that point in time, you'll see that light go solid. Once that light's solid, that's also going to energize, one point I didn't bring up yet, is it's going to energize our motor contactor for our compressor. So up until that point, when it's in a time delay, that compressor will not be running. So keep that in mind. If we are in a time delay period, the compressor should not be running. So I talked a little bit about this already, but of course at startup, our sensor time delay is going to be active. We're going to have that yellow flashing light. That's an 8-minute time period where it doesn't care what's going on. It's basically just letting that machine kind of get up to running condition, kind of normalized, just give it that time to equalize everything out. Now, after 8 minutes and 20 seconds, there's a brief period of 20 seconds just to make sure everything's working. We should see that yellow light go solid. At that point, we should be running. Our compressor motor should have started and we should be making ice. Again, I'll go through this again. If we lose RPM at any point, we're going to flash the LED fast flash, 2 flashes per second. That's going to indicate we lost RPM and that we're in another time delay period. And if we unfortunately repeat that 8 times in a row, then we're going to go in a lockout and we are going to see a solid red light. What RPM are we looking for? 4 to 13 RPM, somewhere in the range of 4 to 13. 9 to 10 is ideal. At 4 RPM, if we lose, or if we get below that threshold, of course, we are going to lock out or shut down. If we go above that, it's also going to go into a lockout and do the same thing. So 9 to 10 is pretty standard, pretty average. That's what you'd be seeing. Now you could figure that out by counting. You can take that sensor out and you can actually see inside and look at that coupling. There'll be notches in it. You can count the times that you see that notch. There's 2 notches per revolution, so keep that in mind. But that'd be the easiest way to verify that you do have operation. You'll probably be able to tell if it's turning or not just by the sound of it. All these machines tend to make a little bit of noise, and you start to pick that up after you've been around them long enough. But if you're unsure, you can always unscrew that sensor and look directly in there. Now, one other condition that we need to bring up is that there's a built-in safety feature. It's basically an overcurrent device to make sure that if we have an overcurrent condition through the motor contactor for the compressor, that we cut the circuit out so we don't hopefully damage anything. If you see a slow flashing red light, so 1 flash per second, not fast flash like before where it's 2 pulses per second, a slow, steady 1 flash per second, red LED on that RPM switch, that is signifying that we have found, or I should say the sensor has determined that there was an overcurrent condition through the motor contactor coil circuit, and that it's in lockout, something is wrong. So if we see that condition, the first thing we're going to want to do, first thing I would do is get out my meter, take an ohm reading across the motor contactor coil. We're going to make sure that we don't have either excessively high resistance or excessively low, so something like 1, 2, or 3 ohms. We do have a specification chart. You can see that on the screen here, based upon whether or not it's a 208 or a 110 voltage machine, or if you have a remote condensing unit option, you're going to have a little bit different system, which we'll talk about. They're going to have a coil that's actually controlling, or I should say a relay coil that's controlling a liquid line solenoid. But we do have values to look for. But what I like to stress, too high resistance, too low resistance, we have something wrong with that contactor coil. Or another possibility is if we have resistance to ground. So we're going to want to probe from both sides of the coil terminals to ground. If we see anything less than mega ohms of resistance, we probably have a coil that's shorted to ground. Now, of course, this is going to cause a high amp draw. This RPM sensor, or rotation sensor, I should say, is going to pick that up, and it's going to hopefully cut it out in time to prevent any kind of a meltdown or a blowout of that relay, or short circuit condition that could be dangerous, of course. So slow flashing once per second, red LED means that we have an issue with the current through the motor contactor coil circuit. As you can see in the wiring diagram, it's wired in series with the motor contactor coil. So it's basically looking for overcurrent condition at all times. Another safety feature that's built into that rotation sensor. So just a couple of pointers here. If we come up to a nice machine, because of the speed sensor, gear motor is turning, but it's still flashing red, something's going on here. Like I talked about earlier, we're going to want to see what exactly LED condition that we have. Of course, if it's flashing yellow, we're in a time delay period, we're just in a startup. That's to be expected. We can always bypass this if we look again for those 2 black wires going into that connector. That is a bypass. You can put a paper clip in there that will bypass the rotation sensor startup delay period. Or we can just wait the 8 minutes and see if it does go straight to solid yellow. If it does, okay, we don't have a problem. We can probably just move on with our day. But if we start to see flashing red, we definitely have a rotation issue. Remember that fast flash, 2 flashes per second, means that we sensed an RPM, something was going on with RPM with that gear motor. We're gonna have to troubleshoot further. Maybe we have a bad gear motor. It's not impossible that we have a bad rotation sensor. So of course we want to verify that we do actually have RPM, that we have rotation. Again, we can see that by unscrewing that sensor. You can see that motor operate when you turn the power switch on. You'll see that auger turn. If we've determined that we have rotation and we're still getting that flashing red light, we can probably safely assume that there's an issue with the rotation sensor and it needs to be replaced. And again, I talked about if we have a slow flash, what to do there. We're going to want to go, this is signifying that we have a problem with our motor contactor coil circuit, whether the coil is shorted out within the motor contactor or we just have a short to ground or maybe bad wiring or something going on where we're shorting out. We're going to have to verify all these conditions, verify that we have a proper ohm reading across that motor contactor coil. If we see conditions that look like there's nothing wrong, we can safely assume at that point that there's probably something wrong with the rotation sensor and that we're going to have to replace that. But again, make sure we have all our wiring connected properly, make sure we don't have any shorts to ground, anything like that that could be causing erratic readings or erratic current draws. Check the simple stuff first before automatically assuming we have a problem with the complicated thing. I mentioned earlier that some of our larger machines, although it still uses an rotation sensor, it does so in a different way. As you can see in this wiring diagram, we have our L1 and L2 coming in. So that's going to straight down to what would be the liquid line relay, control relay coil. So it's controlling a relay that's controlling the liquid line solenoid. When we open up that liquid line solenoid, what that should do in the remote condensing unit is bring refrigerant flow up to it and close our low pressure safety switch. At that time, we should start the condensing unit up and we should be making ice at that point. But before we ever open up that liquid line solenoid coil, we need to establish rotation. So in place of the motor contactor coil, here we're using it to control the relay that's controlling the liquid line solenoid. Same operation, troubleshooting steps, same steps apply to this, same color LED. Everything is the same other than what we're actually controlling changes from the motor contactor coil to the liquid line solenoid relay coil. Now, I'll also point out that on our largest machine, here we show an RFF 2200, RNF 2000. Here we can see that we have 2 evaporators on this machine. And of course, because we have 2 evaporators, we're going to have 2 rotation sensors. They're going to be wired in series, doing the same thing. We just have to make sure that both see RPM before we can engage that liquid line solenoid valve relay. So they're wired in series together. Both of them have to be made before that liquid line solenoid relay coil will open. So keep in mind that we have 2 here to troubleshoot, but they are exactly the same in operation. The LED colors, the flashing all mean the same things. It's just that we're going to have 2, and both of those 2 would need to be in their run condition in order to energize that liquid line solenoid. So that's troubleshooting our Flaker Nugget line in a gist. Now, one thing I want to point out again is that they're very similar in operation between all of them. We're relying on a safety network. All those safeties need to be made before we can start that compressor up and get that machine up and running and making ice. So in almost all these scenarios, we're going to run into an issue in a machine that doesn't start with some sort of a safety. So just remember, check for voltage through those safeties. Find which one's open or closed, replace it, and we should be back to making ice. That brings us to the end of today's monthly spotlight, but we do have a few more coming up in the future that I'd like to talk about. In September, we're going to be talking about Luminice, how to install, how to troubleshoot it. In October, we're going to go over a soft launch, or I should say our hard launch of our Ice Tech FAQs. We're going to introduce what that is. We should have a bunch more up there for those of you who already know what that is. So look forward to that. November, we're going to go over Neo refrigeration system and kind of how to diagnose some refrigeration related faults. And in December, we're going to talk about Indigo next and how to do a proper cleaning. Also, like we have pointed out in the past, for those of you that have watched these before, that QR code that you see on the screen right now will take you to a submission form where you can submit ideas for future content. We are always open to suggestions. We're looking for techs out in the field, some of the problems that you're seeing. With those suggestions, we can use that to create future content, whether it be an FAQ or even a monthly spotlight. That kind of helps us hone in on what you guys out in the field really need to make you guys efficient. So again, that's going to take you to the submission form for ideas for future content. And like I mentioned at the beginning, we're going to talk about our quiz here. Again, you're going to have to submit some basic information, such as your email address. Once you do that and hit submit after finishing the quiz, we will send you a copy of this presentation along with a certificate of completion in PDF format. And also, we are continuing on with the tradition here of our prize giveaway. So, of course, for those who take the quiz, this is going to have to be done within 1 month of the active spotlight. So, in the month after 1 month after the release of that particular spotlight, you have to take this. To take that quiz. If you do take that quiz, you'll get entered into a drawing. Of course, for the swag bundle that you see here, hat, tape measure, tote bag. Now that could change going forward in the future, but right now that's what we're offering. As usual, unfortunately, employees of Manitowoc Ice who are not eligible for this, you can only have 1 submittal per person. You can take the quiz as many times as you want, but it'll only be counted as 1 submittal. We will notify you through email address. So like I said before, if you want to get notifications of anything, please put your email address on there. And for every 25 quiz submissions that we would get, we would do 1 drawing. So if we have 50 quiz submittals, then of course we would do 2 drawings. And speaking of that quiz, here is the QR code for this month's quiz. Also, we'll drop the URL link into the description in case you're doing this on a PC. Again, please put your email information in there. That's the only way we have to contact you. And good luck. Thank you for attending. See you next time.